welcome to another episode of Introduction to Computer Networks. Good to see you all, and let's go ahead and start with the announcements. How about that? Yeah, good afternoon. So I think the first two bullets are all kind of trivial, so let's just skip that. And let me go to the bullet 3, announcement number 3, gentle reminder. PA1 as well as the quizzes for the second week. So we'll have 3 quizzes during the end of the week and 1 PA doing at the end of the week. Okay. All right, and bullet number 4. So the TA and I would like to ask kindly that you check the post on the workspace before asking questions. Chances high that the questions you have, other students do have. And if the other students post the questions online somewhere, they might have been answered. So so check the workspace before you ask. The answers you are looking for might be on the workspace already. Okay. And it could also be in one of the announcements Polly just posted. Okay. So if you did have the notification on, you will see that the PA assignment, you may start working on it already. The accounts are assigned and they are enabled. So you can go log on the PA assignment workstation and then try to complete PA1. And I think some of you might have been starting working on PA2, 3, or maybe 4. I don't know. I am very often surprised by the students. And you know what? Yeah, Polly said that in the first day of course that the ACCO will be distributed on Thursday, 5 p.m. Turned out that I was able, because we've done quiz 2. And I see pretty well that who will add, who will probably not add, and who are already in the class do plan to drop and join another very hard to get in course. Okay, so I've already distributed 11 ACT codes. That should take the course size to about 38, 39, potentially 40. Hopefully that's not go over 40. So this is a healthy size with Aaron helping me. All right. And so you see, if you go back to the posts that you did not see the notification for, you might see that some of the questions you have been answered. And bullet number 5 here, point number 5 here is this. Hey, try to be shameless. Okay. Hey, Polly has been shameless. I know it was very embarrassing seeing me on YouTube channel. I couldn't bear watching my own video, really. So, hey, you're encouraged to be shameless. Post the questions on the workspace. And in order to get the responses effectively, you will want to post it on the corresponding channels, right? If it's questions about PA1, go to PA1. And if you have a question you want to ask, you definitely want to come here because, you see, Naiming here is making a suggestion, which is very nice because Windows 10 Plus now have a default, have a built-in SH client. You don't have to download like what was the one I recommended? Like PT, I forgot exactly, PAT, whatever. There are some SSH clients, open source SSH clients available, and I recommended like 1 or 2. Now if you are a Windows user, you could just use the built-in SSH and bypass the step of installing your own SSH client. Alright, so you see, nice, isn't it? So post your question, and of course, learn from Naiming, post suggestions. That way, hey, everybody learns. Alright. So again, the mode of the class is, just see if we could learn from each other. And of course, part of the learning is asking. The more you ask, the better you know how to ask. So how to ask a question is also something that you need to learn. Okay, so that's practice. So it's nice that you post these questions on the workspace that's shared, openly visible by everyone, because hey, when you ask a question, you also provide opportunities for the class to participate and earn extra credits. And you allow others to see the questions. Allowing others to see the questions they might have been answered. So if you ask a question and they have been answered, then others who have the same questions can just see the answers there without needing to ask again. And hey, this is also the way you receive and answer the fastest. Because usually there will be some delay for Aaron to see the question and for Polly to see the questions. So Polly is in and out and having meetings, and Aaron is also taking courses and working on projects. So of course you guys are all busy, but you see that the more of us are there, the chance is higher that we get an answer and we get a question answered faster. I mean, it's just that. For Q&As, the more the merrier. Good, so those are the announcements. And this semester I'm trying in a way that if you just click the PA1, it takes you to the PA1. And if you click week 2, quiz 3, so as I'm resting on it, you probably don't see the cursor from the YouTube stream, but you see that there's like a dialog box suddenly showing up. That's because my cursor is now resting on the W2 quiz 3 channel. So you can click in there and for example adding yourself in and see the questions of quiz 3, for example. And by the way, Polly would pose the question for each of the quiz. Polly will pose the quiz just slightly before the time that we'll bring up the quiz. Right? So now if you're clicking there, you don't see the quiz yet. Okay. Good. All right, and so that communicate all the to-dos for this week and what Polly and Aaron would like to communicate. Now let's move on. Let's recall what we finished discussing last week. I think we started talking about internet, the physical view. We see the components such as end systems, remember? Yeah, the laptops, smartphones, or computers are end systems. And we have this thing called access network, right? That connect us to the core of the internet, which is an interconnected network of routers. And these access networks, there are various technologies that they all come with different bandwidth and stuff like that. Okay, so that's a very high level view of how the internet is like physically. Okay, the hardware part of the internet. Okay. Next is to show you, you might be surprised the kind of variety we have as end systems. All right, so let me say a little bit more about the end systems with this slide. Laptop, PC, servers, smartphones. These are the things we typically use to connect to the internet. But nowadays, if you go to these electronic shops, if you go do a little bit shopping on the Amazon or PC Home, you see there are these generation of new things coming along, and they can all be connected to the internet. They're called these IoT, the Internet of Things. Yeah, things is a very general term because these things don't have a specific form. So they could be internet-capable toaster, internet-capable power meter, internet-capable mattress, internet-capable fridge. And this is a picture frame. Okay. So for example, Twit a Watt. This is a smart meter that connects to the internet, and this meter can actually take the reading and go on Twitter and tweet the reading itself. you can imagine that the power company, power suppliers, energy suppliers can just, take the readings from Twitter without, taking a trip, okay, to your home. Smart mattress, right? So this mattress can sense how you sleep overnight and provide some feedback to you. This can further be made into something that's a little bit robotic, not just being capable of sensing, and so try to adjust the firmness of the mattress so that to ensure you have a good sleep. Smart fridge, I always like to have one of these. So it actually takes, there are cameras inside, so they take actually photos of the milk. So sometimes when I was, in the grocery shop, I would really like to know whether I should be buying milk today. So this smart fridge will be able to remind us, okay, when we're in the grocery shop, whether it's time, okay, to buy milk. Picture frame. I think this is one of the very, very old IoT device. It's connected to the internet, and it was using a way that, hey, so you guys can send recent pictures through these IP frames to your grandpa. So you give these IP frames as a gift to your grandma, and so that every day they kind of see different pictures from you. Now this one is Polly's favorite. It's a smart toaster. So what it does is that it will go on the web and retrieve the weather. Okay, and so when you're making the toast, you kind of burn the mark corresponding to the weather today. So as you're eating it, you know the weather seamlessly. Okay, without needing to check on the web. Nice, isn't it? Don't you just love the toaster, right? Those who like it, say yes on the chat. Now, the next video, it's also brief to just, summarize the physical internet. And so those covers kind of all the components that's composing this very coarse-grained internet. But on top of the physical structure, there are also these rules, okay, that's controlling sending, receiving of the data, right? Such as, this is probably the third time that I talked about this term, TCP. HTTP is the protocol, the set of rules, okay, overwatching how you send data over the web. Yeah, so pretty much for each of the service, there is a specific protocol. For each type of service, for data transferring, there is a specific protocol. And so you see, in general, the internet is a network of networks. So this is what? A network of a subnetwork, right? So institution network is a network. Home network is a network. Global ISP forms a network. Regional ISP forms a network. And the internet is actually the bigger network of all these smaller networks interconnected each other. And it's loosely hierarchical. Why? If you look a little bit closer, yeah, this mobile network is connected to actually a higher tier ISP, while this home network and institution network is actually connected to a lower tier, a regional ISP. Okay, so it's not necessary that mobile network is, level 2 or level 3. Okay, in this case, it's actually level 2 at the similar level as the regional ISP if, they share the global ISP. All right, so this is what I meant here. It's loosely hierarchical. Right? And there are parts of the internet being public, okay, meaning everyone involved, okay, in the society, in that region, okay, they will try to donate and to take part in contributing the expense of running that public part of the internet. But for most part of the internet, it's now private. So for NTU, an institutional network, to access the institution's ISP, usually we pay. Okay. Similarly, at home, you pay the ISP for access. Similarly here, if you're using 4G, yeah, you pay someone to get access. So these, as long as you're paying, that means you're accessing a private network. Okay. There are occasionally public network, not a whole lot, but usually public network, the reason that we don't pay is because essentially we are contributing part of the work, okay, sharing part of the cost already, okay, by forming a consortium and paying a specific membership fee. Yeah, so internet, it looks hierarchical, but it's not very strict. Second, from that video is that you begin to see, so there's a physical infrastructure internet, right? There are computers, there are access network links, and there are routers. But there's also a software side, right? In order to let these hardware run seamlessly, right? You need to have softwares implemented on top of it and working on top of it. Those are called the protocols. Okay. So the next few videos is to talk more about the software side of the internet. That's Internet Service View. Now the service view. Okay. To explain, we've learned, right, the nuts and bolts that's composing the physical internet. That is the communication infrastructure to allow us to actually have these applications sitting at the very top, at the first place. But the communication infrastructure on its own will not be allow us to send data really that freely. So we could do surfing, we could send emails to each other. Between the apps and the infrastructure, we still have a number of these communication services defined by these protocols, okay, that's running on each of the devices, running in these routers. Okay, so there's a software component, a service component there as well. Now, two major classes of services that are provided by the internet are these: reliable data delivery versus the unreliable data delivery. Okay, so internet, essentially, it's not just a physical infrastructure, but also an infrastructure with software support so that we could run all sorts of distributed apps on top of the whole thing. There's just one thing I want to clarify. For unreliable data delivery service provided by the internet, a lot of times we just call them the best effort service. Yeah, I know it's a little bit counterintuitive because reliable data delivery is obviously better than the unreliable data delivery. Okay, so why calling the unreliable service the best effort service? Yeah, take note here. We're saying this is best effort service. We're not calling it the best service. Yeah, this is a kind of a polite way of saying that, hey, there's no guarantee. If you recall cases where your friend's asking you for favors, but you are not, that you don't have time for it already. So a lot of times what you say to your friends, right, politely, is, I'll try my best. Okay, so that's what we meant here, calling these unreliable data delivery services the best effort services. All right, and next, let's talk about the protocol, this term a little bit more. This is so that I can impress you more about this term protocol. It is a slightly more formal way of calling a set of rules, okay? Calling a standard way of parties communicating with each other. All right. So two very simple examples I'm giving, and as analogy to another. One on the left is a human protocol, okay? One asking for another person for information. The other is an internet protocol. One end system asking another end system for information. So you see here, very often when Alice wants to find out what is the time, she says hi, right? And then maybe a friend here catching, Alice needs a bit help. Bob says hi back, okay? Showing that, okay, what do you want to know? Alice says, have you got time? And Bob provided the information that Alice is looking for. Similarly, we as users might be sitting in front of a desktop using a web browser trying to get the content from this URL. So yeah, that browser sends a message to the web server that holds the content. And that server will say, sure, you got my attention. What are you looking for? Client sends, I'm looking for this page. And server sends back the content, okay, of that URL is indicating to. So that is a simple protocol in human world and in the computer world. To sum it up, a protocol, it can be a human protocol or a computer protocol. Okay, so that example you just saw is for Alice to ask Bob for a time, a client asking for a server for certain information. Or for you to ask a question. For example, if you raise your hand, right, that's like you saying hi. And if Polly noticed that, Polly says, "Oh, okay, good. What is the question?" Then you start by asking the question, Polly answering the question. So that is the protocol to get a question answered. Okay. So for people first meeting each other, how do you introduce each self to each other? Yeah. So there are specific protocols that allowing human to communicate with each other. Okay, so they are usually involving specific messages and specific actions taken after the messages are received, right? And then so on and so forth, right? You know what? That's very similar in the computer network, okay? And the parties involved are just simply replacing humans with machines. Okay? And so all these communications happening in the computer network, okay, are governed by these protocols, where we define messages being exchanged and the orders of them being exchanged and the actions each of these computers, each of these entities, okay, need to take after receiving certain messages. And that takes us to quiz 3. Yeah. So here goes. Well, Polly actually enjoys reading. So this is one article Polly discovered from Wall Street Journal back in 2013. The delicate protocol of hugging. Okay, so what the article says is this. Greeting is something that we do every day. It's simple, right? We say hi. You guys say, "Good afternoon, Polly," to me, right? Just like 20 minutes ago. Seemingly very simple, but it's in fact also complicated. Okay, look at that picture on the right. Right, so the guy is hugging the lady, and the lady was not exactly comfortable about the hug. You see, and in addition to this uncertainty of how the people you're greeting with, how they perceive how close they are to you. That is something that is a little bit hard for us to know, right? So I think let me borrow from the Japanese culture recently that so people working in a company needs to know how to read the air. Because in human communication, some of the protocols are implicit. It's never really clear. That's what the article meant to say. It can be complicated to greet. So in addition to how the relationships are close between the two people greeting each other, it can also depend on what culture background the person you're greeting with is. Okay, so Americans like to hug. Latinos, Europeans do this, kisses on the cheeks or touches on the cheeks. Okay, Japanese, when they are dealing business, they bow to show that they are really sincere. And I guess in Taiwan, most of us just shake or just simply say, "Hey, hey, hey," something like that. It sounded really casual, but it's the ultimate Taiwanese way of greeting people. So the other one does not feel any pressure at all. But from for example, exchange students coming from other culture, it might appear a little bit impolite. You see, so it could also be culture background dependent. Okay, now a lot of us also implement this. Try to be polite and wait until others initiate greeting first. But you see, that might also appear like you are a little bit reserved, not as open or passionate about meeting the person. And if that's not the message you want to give, maybe wait until they greet you isn't the best thing to do. Okay. So, question: how do you know, right? You should be active, right? And bow, shake hands, hug, or do the kisses on the cheeks. How do you know, right? When you run into a person you don't know yet, how would you like to greet them? Can you define your own protocol of greeting? All right. Now, again, this is a team effort. So do try to find your teammates. Now, some of them might not be around. Then you'll have to, be creative and improvise, and ask them to attend the lectures maybe next time. So, for this quiz, this is Polly's demonstration of what an open-end quiz is like. Okay, so you're allowed time to discuss and converge. So you will be given 8 minutes of time. So it's currently 45. We'll try to come back to discuss and check your answers that you've posted on Slack, okay, the W2 Quiz 3 channel. So after that, after checking the quizzes, we also have a discussion, but mainly Polly walking through your answers and see if that inspired Polly's of adding more. So 8 minutes, go ahead and start discussing. We'll try to converge and come to the Quiz 3 channel and go through what you have. And this is the music Polly plays during the quiz time. All right. Yeah, we do have a visitor. Xiuhan, I think it's one of the, one of the former students. I think last semester? Sorry if we disturbed you. Now, if you are having lunch in the meantime, finding something entertainment to watch, feel free to say. All right, you see, wow, we have so many teams, right? Yeah, submitting their solutions. Let's see. Team 1, Zijun, wow, always the fastest. For those first met, asking first. Oh, wow, simple and crisp. Simply ask. Is there like a way that I better greet you? Exactly. I think this is very straightforward. Team 12. Yeah, so similarly, right? Like team 1, you ask what is the best way, and of course, then the person you're running to will suggest ways to do it. And then you agree back. Great. And okay, Zhongming is speaking on behalf of Mu Bai. Just do it. Yeah, I think this is a very guy's way of greeting. I think if you are greeting a guy, I think it's very manly. I can see that how it's easier to make friends this way. Yeah, very straightforward person. You've gotta love a straightforward person. So these are the type who don't lie and hide things all that much. Okay, Mu Bai, good for you. Good for you. And Zhongming, you're Mu Bai's friend, right? Also good for you. And Claudia was saying, create a protocol, and in the meantime, giving an example. Just simply ask, right? What is your nationality? Where are you from? And according to where they are from, and act. Kevin here. Okay. Reach the hand out. Try to engage a handshake. I think that's a very neutral way of doing it. It will never be offensive. But in the pandemic, maybe elbow shake instead. Naiming, team 8. Oh, okay. Okay, so what Naiming is saying is a little bit different, right? So depending on where we are doing greeting, not exactly based on the cultural background of the person you're greeting. Interesting, right? Yeah, in Taiwan, even for exchange students, you won't be surprised, right? If the local people try to greet you their way because they didn't know better, you probably won't mind much. I think that's a good point, isn't it? Just love to see you guys coming up with very different answers. Waiting for the other to move first and do what they have done on you. Okay, good. I think this is a little bit similar to some of the earlier solutions we saw. Oh, Anna has a good point here. Because, hey, Polly shared, right, from that Wall Street Journal article, right? Europeans do this, and Japanese do that, Taiwanese do this, and Americans do that. But what about Africans? Do you know exactly how they greet? Beats me. It's not like them, irrespectful. I am just not sure how they do it, right? Please tell me when we can find download PAs. Oh, okay. Anna is asking a good question. Hey guys, help. Okay. Direct Anna to the PAs. And there's another solution from the same team of Claudia. Okay, Belen. Before asking about their nationality, keep reading their body language. Oh, okay. Yeah, so I think it's part of this read the air thing in the Japan's kaisha culture, company social culture. Okay, Belen, you've captured the subtlety there. that the article was talking about. Nice. All right, so allow Polly to do some time control. I would love to go through all your solutions, okay? But let's try to do that after we are done with the goal today, all right? Great to see you very active there. Now, the point of the quiz is this. You see that human protocols subtle and a lot of times implicit, so that we make all sorts of mistakes when we are making friends. In order for computers to communicate, the network protocols, hey, you don't want that you ask for a page, you try to download the PA, but the server is not returning you the PA. No, right? That's not supposed the technology should work. So, computer protocols, network protocols, they are always clearly defined. And the programmers of these protocols would definitely need to follow exact definitions of the protocol and implement accordingly. So that includes, hey, what messages there are, the format, which message will trigger the next message, and the timing the messages should be fired back. All right? Good. Now let's try to wrap up the overview of the internet. Now to wrap up, what have we seen so far? Yeah, we do have these hosts or end systems where we run applications. They are sitting at the very end, very edge of the network. And these end systems connects to the internet through the access networks or communication links. They can be wired or wireless, okay, and through different kind of physical technology, physical media technology. And then finally, reaching the core of the internet, okay, which are essentially interconnected routers. Okay. And with all these together, we see the internet is a loosely hierarchical network of networks. All right, so this is the internet. All right, so next we'll go down, we'll try to dive in a little bit deeper and look into the specific components in the edge of the internet, and later on, of course, the core of the internet. So here's the overview of the edge. Now let's take a closer look into each of the components, and starting from the edge. So essentially, we have lots of these end systems running applications at the edge. Two very dominant examples, web and email. So for example, this guy here, a laptop. This guy here, a server. Okay, usually server are higher end machines having more computation power or higher amount of storage. So web browser will be talking to a web server requesting for a web page. Okay. So that is called client-server model application, where the client requests for services and receive services from the server. And you see that the expectation of these servers are that they run all the time, 24/7. And that's why these servers need to be higher-end machines, having more computation power, having higher amount of storage, and have more reliable internet connection. Okay, so as we mentioned, web browser here, web server here. Now, some of the pairs could be running email. Then you have email client, which is typically the email reader, and then there'll be email server. So these email servers usually you don't get your hands on. Okay, you don't see them. Just like the web server, you don't typically see a machine. Okay, physically that is a web server. There's another way of communicating the end systems, the applications running on the end system, that is called the peer-to-peer model. Okay. The idea there is to get away without this, always on server. Now, imagine, right? Setting up a web server yourself and allowing thousands and maybe millions of clients in the world to access your web server. You do need a lot of money, right, to maintain it. But some applications might be more grassroots effort where you don't want to be able to afford servers and yet you still want to be able to exchange data. Yeah, that is what the designers of these peer-to-peer applications are thinking. Let's minimize the use of high-end dedicated servers. And instead, why don't we, right, smartphone, laptops, desktops, laptops, just, connect directly as peers, one to another. So there do exist several of these peer-to-peer applications. Skype is one example. BitTorrent, I'm sure that some of you have used it before, is a very dominant example. It's still very popular now. And besides these two, there's one example that you might go, oh yeah, that's right. It's called the Bitcoin or cybercurrency. So that blockchain allowing the cybercurrencies to track itself is a peer-to-peer network. So there's no particular server. That is the whole idea of having these virtual currencies. Okay? Instead of having a central bank to overlook everything, to track, record everything, to monitor any of the currency exchange, virtual currency, Bitcoins, it's completely distributed. It's peer-to-peer. All right. But guys, guess what? The cybercurrency, they don't want to be centralized so they can avoid the control of the centralized currencies. But you know what? Turned out that it's still influenced by the centrally controlled currency, isn't it? Right? When the US raise interest, US dollars rise, money market is, in a panic, and the cybercurrency gets affected. So I think just that the system being decentralized, distributed, or peer-to-peer doesn't necessarily mean that the things that you're keeping, the data you're keeping there, or the value of the data you're keeping there will be still decentralized. And last video today, now we are in the edge. And the most important component in the edge, of course, is the end system. But there is another thing, the access networks. And there is a variety of access networks. So let's take a closer look and define what access network is first. Now let's move a little bit inward and talk about the next component, access networks. We know by now access nets are there to connect the end systems to the edge routers. What we haven't talked about are that there are several of these access net technologies. In fact, in the next few slides, Polly is going to talk about 5 of these. And depending on where they are used more often, they are classified into these 3 categories: residential, institutional, and mobile. Residential meant home access. So some of these access net technologies are used more at home, deployed more for home environment. Some of these are used more for institutions such as NTU. And some are wireless, okay, so people can still access internet as they're on the run. For example, 4G is a mobile access network. Now, as Polly gets into the details and talk about each of these access net technology, try to pay attention to the bandwidth each of these technologies promises. Some of them offer higher amount of bandwidth, some lower amount, and some offers symmetric amount of bandwidth between downlink and uplink, but some offers more downlink and less uplink. Pay attention also to how the access net is being used among the users. Some access nets give you this amount of bandwidth, but all the users accessing the network will share the bandwidth. So if there are more users, each one gets a smaller cut. But some technologies actually offer big bandwidth, and that access net will actually allocate a specific amount to each of the users. So each of the users will be guaranteed a specific amount, which is dedicated. Okay, and if there are more users, none of the existing users will suffer. All right, so that's all the time we have, and yeah, so the rest of the time will be, of course, Q&A, or I see there are some comments. Cryptocurrency is a scam. Okay, it's probably because people was treating crypto speculation. I think Jen N, you got it right. Yeah, because the value of the currency is really what we think, what humans think the value is. And you see that we still live in a physical world. Okay, so for physical goods, we still need a centralized currency to do the buying, selling. So it's really hard to make crypto entirely decentralized and not being connected to the centralized currencies there exist. Very interesting point. Thank you for joining the discussion. And it's already 2:09. Let me just kindly say that I will see you tomorrow morning, and we'll continue to talk about access network. In fact, we'll go through each one of them: ADSL, cable, FTTH, Ethernet, and wireless. Okay. Again, as I mentioned in the video, try to look for the amount of bandwidth each of these technologies provide, and whether they are shared or dedicated. Good. With that said, bye. See you tomorrow. Okay. And Polly will keep checking solutions from other teams about the greeting quiz. Have a consensus about how to express. Okay. Yeah. Churong, you did not mention which team you are, but you are obviously very computer thinking. Computer-oriented thinking. Very good. See you. Bye. Bye. And oh wow, okay. This team here has many emojis already marked. Okay, bye. Say hi first and see if the person do anything else. The person want to shake hands. Okay. Yeah, hi. It's very easy, right? Hey. I think it's neutral too. Since I'm a man, I would rather just wait. Yeah. I'm being a disgusting man. I hope not. Yeah, but I can understand this. This is probably, to make a good impression at least. Oh, sorry about that. If from other culture. Yeah, I think I saw somewhere that one team was saying that making sure where they are from and then Google up how they agree. On team 5, step 1, ask your mate. Sure. Greet. I see. Shake hands. I see. Yeah, very standard. As a modern human, maybe we should just ask Google to answer. I wonder what Google would say. How to greet another person. Or what Siri will say. Hey Siri, how do you greet another person you don't know where they are from? 16, be passive. Waiting. To avoid being disgusting, right? Oh, sorry. Guys. And team 4. I thought you guys answered already. Okay. I guess Mumbai is not in the same team. Wait a minute. Okay. Oh, bye. Hi, shake hands, hug. Okay, I see. High is the most neutral, right? So you kind of observe from the gesture, expression, and how open-minded the person is, and decide to which level your greed is, how passionate your greeting is. I see. Oh, okay. Wow. A Facebook link. Let me see. Let me avoid moving away from the Slack workspace. It's a video. Interesting. Oh, I see a video. You learn how to greet people from very different background, a variety of backgrounds. Cool. What kind of greeting is this? Wow, interesting. And Yo-Yo, you can observe. We can observe that others are doing an imitate. I see. Yeah, you copy what they do. Version 2. Walk towards the person. You say, okay, this is a very detailed algorithm, right? Very fine-grained algorithm. Else if pseudocode, wow. Okay. Perfect. Pseudocode. You pay attention in your data structure course. You are discussing. All right. All right, so yeah, that's all. And let me end the stream here in case some of you are still online. Yeah, so let's see each other tomorrow morning.